Hi, this is Kevin Trainer. Welcome to the tutorial for exercise 3 of our coding assignment for uh, the Zelle third edition, chapter 5 from the Python book. And in this tutorial exercise, we're going to begin to do some really useful work. And here's what we're going to do. We have a file of names. It's called employee names .text. Okay, and it's just first name space last name. Okay, one employee per line, and we have 125 of these employees. And before you worry that I'm disclosing some of these names, these are phony names that I generated a couple of years ago for another course from some website that generates phony names. Okay? Now, this is interesting information, but it turns out it's not what we want for the task we have at hand. Okay? We want to be able to sort the names into conventional alphabetical order, okay? And if we sort these strings with the normal sort utility that comes with Python and really almost any normal sort program, it is going to put it in first name and then last name order. Well, that's not what we want. Typically, when we sort things into order, we want last name considered first and then first name. So the way that we typically solve this is we come up with another format for this, and this is what I'm showing you here. We transform the file of names into another file, okay, that is in another format for the name. And a lot of people call this a sort order name, okay? Now, what do they call the regular order? They call it the natural order. Okay, so here in the West, here in the US, the natural order for names is give a name, then surname. We call that the first name and the last name. So for Elizabeth Wilson, the natural order name would be Elizabeth Wilson. And then her sort order name would be Wilson, comma, space, Elizabeth. Now, how's a sort order name helpful? Well, if I took this file and I sorted it with a typical sort utility, it would sort it by last name first and then by first name, which is exactly what you want. Okay, so how do you get one file that's in the natural order for names, and how do you transform it and create another file that has the names expressed in the sort order? Okay, and there's so many problems like this, where we're going to take a file and we're going to transform it record by record, line by line, and we're going to take the data from the input and we're going to in this case we're going to rearrange it. Okay, we're going to reformat it, but we could do things like this. For instance, I'm giving you a foreshadowing of some work that you're going to have to do later. Maybe we want to take the first name and the last name, and we want to compute what their user ID name would be. Okay, maybe we want to have that included in the output. Well, we could do that too. So this kind of general style of program is transformation. Okay, and we read a file in, kind of line by line, and we transform it line by line, and as we transform it, we write it out line by line. Okay, and I do these things all the time. Unfortunately, I have to do this a lot. The names that I get from the learning management system wherever I teach, um, as they change the learning management system, they come in a different order. Okay, so I'm forever writing a program exactly like the one that we're going to do now. You would think that the features of these learning management systems would be that you could ask for the names in several different orders and formats. Well, they don't think so because they give you the names the way they have the names. Okay, so we're going to read names in this natural order, and we're going to write names in this sort order. Okay, and here's how the program's going to look when it works. Okay, it's going to prompt the user, uh, please enter the name of the file containing names. Okay, and there's a starter file if you're following along at home, employee names .txt, and then it's going to process it. Okay, but the output's not going to go to the printer. The output's going to go to a real output file. Okay, so here's what we say. We say 125 lines were processed from input file. Then we have the name of the input file, employee names.txt, skips a line. Created sort order names file as sort order names.txt. Oh, okay. And when I ran the program, I got sort order names .txt. Okay, how do we know that? Well, I'm going to close this. I'm going to delete sort order names .txt. Delete it. It's not there any. Oh, do I want to delete it? Yes, I do. Now it's gone. Okay, and now let's uh, where is this? Oh, convert names to sort order. Well, I don't want to show you the code yet, so let me open it up off screen. Okay, and uh, let me get ready to run it. Yeah. Okay, because I didn't want to show you the code too soon. Okay, so let me zoom this out. Please enter the name of the file containing names. So employee names .txt, and it ran that. Okay, so did it create a new copy of this? That's not what I wanted. Did it create a new copy of sort order names? Yes, it did. There they are. Okay, and to me, it's always interesting how fast these things run. Like 125 names are transformed in just a second, very very quickly. Um, it's only when you really begin to work with really big data files that you see really any pausing at all. Okay. All right. So this is what we're doing. Let's create this. Okay. Now, do we have the data that we need? No, we don't have that yet. Okay. So we're going to need to bring down from the starter files. Let's look in downloads and the starter files. I have another file that I need. It's called employee names.txt. So again, I'm going to highlight it, right click and choose copy. And then I'm going to highlight the name of the data subdirectory, and I'm going to right click and choose paste. And then it's going to confirm the name, and there it is. So if I want to look at employee names, they're right here. Okay, so again, you want to make sure that you create that subdirectory. All right, because we're going to be We're going to be expecting you to put the data in a directory called data, and we're going to expect you to have the names of the files be what we expect, and we're going to expect you to copy in any of the starter files that you need, okay, and leave them there for us to use when we grade. All right, so there it is right there. Now let's create our program. We need a new Python file, and it's going to be called convert names to sort order. Okay, and we don't put an extension on it because that's going to be done for us. And let me start to bring over the code. All right. Again, I'm going to copy it and paste it because you don't want to watch me type. Okay, so here's my doc string. From a file of names, generate a file of sort order names. And I might want to say this. Maybe I'll be a little bit more explicit. And I'll say from a file of natural order names, and that's what the people in this people who are in the business of distinguishing these kind of names from each other, that's what they call them, natural order names and sort order names. So from a file of natural order names, generate a file of sort order names. Okay, pretty easy transformation. Okay, and let's go all the way down here and have a call to main. Okay. All right, so let's do the kind of introductory stuff, what I used to call housekeeping. Okay, so we're going to count lines again. Why do we count lines? It's the polite thing to do. It's often a problem when you're testing things and you're running things that all of a sudden you seem to be missing data. Okay, and you're going to say, gee, did one of the records or 10 of the records or 100 of the records get eaten in one of the programs that transform the data? Well, if you put out these counts, these kind of record counts, sometimes called control counts, it's a real easy way to look back and see where you might have lost the data that you weren't expecting to lose. So line count, again, we're going to hard code the name of the sub directory. Again, would we do that in the real world? It depends. If in the real world all of our users were putting their data in the same place, well, then we would do that. If not, we probably would prompt them for it. Okay, but we're not going to do that. It's always going to be in the data subdirectory. And then we prompt the user for the file containing the names. Okay. Then we have to combine the subdirectory name with the proper file name and put a slash in between it in order to come up with the expression that we're going to use when we open the file. And one of the things I want to point out here is that not all that long ago, even a year ago, I would have been doing this with the plus operator. I would have been doing this with strings and the plus operator. And now I think the right way to do it is with an F string. Okay, so all we're doing is that we're taking the directory name and then we are putting a slash in between and the file name. And I've read some articles that say that this is actually faster than using the plus operator. Now, I don't know if that's actually true, but I'm using it as the rationale for using F strings whenever I want to do combinations of string values. And they're very good documentation. And then, of course, we do the open, right? There. Okay. Now, what are we going to do now? Well, we need an output file. So let's go and put more code here in this kind of top part. We're just, we're getting ready. We're sort of initializing things. Okay. Now, I've decided that we're going to hard code the name of the out file. Okay. Is this good user, is this good interaction design? What I'm trying to do is while we're testing this, I don't want you to have to, I don't want you as the user to have to type in too many file and directory names. In the real world, we might prompt for this. Okay. And then again, we have to build this string that's a combination of the name of the directory and a slash and the name of the output file. And now we're going to do an open. Now, one of the things I realize is we have a possible third parameter on the open, and it's encoding. Okay? And we're going to say encoding equals UTF -8. Okay? And it turns out that characters have an encoding. Python characters are Unicode. And the simplest encoding here in the West is an encoding called UTF-8, and we want to make sure that that's the encoding that's used for the output file. Okay, so we've got that. Okay, so that's all the getting ready. All right, let's do the loop. Okay, so I'm going to bring the whole loop here to you. Well, that doesn't look right. I think we need to indent that. For those of you who haven't already figured this out, if you have a block of code that you want to indent or unindent the whole thing, you can highlight it all and use the tab key. So to indent, you press the tab key once. Let's say I accidentally indented it. I hit it twice. I can do Shift tab to unindent it, or undent it, as they say. And I have a squiggly line because I have too many blank lines. Okay. So here's what we're doing. Again, we're doing the classic for line and in file. Okay. And we're going to count the lines. We had initialized it to 0, and here we're doing plus equal 1. Okay. And here we're doing something that's kind of classic. Okay, and I really want to call it to your attention. Let me make this a little bigger. Okay, we're taking the line and we're splitting it. Okay, so it's being split into words. Okay, I made sure that we only had first name and last name, given name and surname. Okay, so this is pretty easy. You sometimes will have extra names. You have to hunt around for them. To do that, you really need if-else kind of logic, which we're going to get to in Chapter 7. So here I've simplified it. But line split, okay, what comes out of line split? Well, every time we run a split, we get a list of all of the substrings. Okay, so this is going to throw off 2. What we're doing on the left-hand side here is we're doing a technique called unpacking. Okay, line split throws off a list, and we're unpacking the list into two explicitly named, helpfully named variables. Okay, now it's entirely possible for us to put this into a list that has a name. Maybe it would be called name strings. Okay, and then we would have to refer to the first name as name strings index 0 and the last name index 1. But the way that Python programmers really do it is they unpack the list into these regular variables, individual variables. We call those scalar variables, okay? So that we can use kind of programmer-friendly names, first name and last name, okay? Now we have to get ready to print. Okay, so we need a string that's going to be in the other order. We need the last name, comma, space, the first name. Well, what a great job for an F string. So down here, we call that sort order name, and we create an F string that has the last name variable, a comma, a space, and the value of the first name variable. Okay, and then how do we write out to a file? Well, the easiest way to write out to a file is with the print. So what are we printing? Sort order name. That's what we want on the line. Okay, how can we make sure that it goes to a file rather than to the console? Well, we give it this keyword, a parameter, where we say file equals out file. So file is the name of a keyword parameter, and out file is the name of the file object that we're trying to use. It's our output file. Okay, and one of the things I'm going to point out is whenever we're using a keyword parameter, we don't put a space. We don't do this. And in fact, if you try to do that, PyCharm, it tells you that it's a PEP8 style violation. Okay, with keyword parameters, they're always right up against each other. Okay, why? Well, it allows us to distinguish them from ordinary assignment statements that look like that. Okay, so again, what are we doing? Well, for each line in the input file, we're counting it. Okay, we're splitting it. We're unpacking it into two very useful variable names. We're formatting the output using an F string, and then we're printing the output to file out file. So, I mean, there's all kinds of things that you could do. You can imagine a lot of transformation of names and things that could go right in here, right? You know, whatever you would want on your line, okay, you can do through a combination of the variables that came from the split and the unpacking, and then you just combine them the way you want in your F string, and then you're ready to print them to the output file. Okay, do we have any more code? Well, I'm just going to give you all the code before we test it, even though maybe that's not the way I want you to do your work. Let me just give you the rest of the code here. Okay, here's the rest of the code. And this. All right, so let's walk through this. So we've gone around the loop and we've written all the records to the output file. Okay, and now we just need to print the polite messages that help the user. Remember, all these names that we just did, they're not going to the console. So the user who runs the program, if we don't print summary messages, they're not going to see anything. How are they even sure the program ran? Okay, so to increase the usability, here's what we're going to do. We're going to print two messages. We're going to skip a line before each. You can see the \n. And the first one, we have the count of the lines. Lines were processed from input file, and we're giving them the name of the input file. We're not giving them the whole combination of the path and the file name. We're just giving them the file name. Okay? And then here, we're skipping a line again, and we're saying created sort order names file as, and then we're giving them the output file name. And then again, always close your files before you're done. Okay, we closed in file, we closed out file. Okay, now let's give this a test. Okay, we're going to run it with employee names. Okay, so let's do this. Let's run, and let's say it's employee underscore names dot text, and then we run it, and it says 125 lines were processed from input file employee names dot text, created sort order names file as sort order names dot text. And now you see sort order names dot text is here. Okay, and let's double click on it, and let's see it up here. And there it is. Wilson, Elizabeth, Lewis, Victor, Patterson, Christopher. All done. So, just to come back to the program, let's just look at the program. Again, one point I'm going to make is that we're almost at the limits of how much code we want to cram into main. Okay, when we get to chapter 6, we're going to learn about creating our own functions. And if programs get much longer than this, we're going to start to divide them up. But this pretty neatly falls in just about a nice size for main. And again, we do the initialization and the file opening. Then we do the looping around and the transformation. We read, we transform, we write, and then we give a couple of polite messages that are useful for the user to track their work, and then we're going to close the files, and then we're out of here. Okay, so what you're going to do is similar but not the same. It's another kind of transformation of the names. And I wish you luck with that, and I'm going to say bye until next time. Bye-bye.